Okay, so this is another walkthrough for chapter 6 with the normal curve. And certainly go watch Dr. Stevens' videos. He'll talk you through all how to do it with the tables, and it's a useful his videos are useful in this. The purpose of this video is to show you how to use another tool rather than the z-score table, because in a lot of ways the this website I'm going to point you towards does a lot. Now, again, I'm going to go to that online statistical tools page in Canvas, and you see that normal CDF, normal cumulative distribution. Uh, um, what's F? I don't remember. Frequency distribution. That's what it is. So I'm going to click on that list, and this takes. Oh, wow! I got that link wrong. Normal CDF. There we go. I guess I clicked on the wrong link. So this is a David Lane applet. David Lane is a science teacher or a stat teacher, I think down at Rice University. I don't remember where he is at. Probably, maybe he's retired now. But he developed this and your graphing calculators, if you have one, does a similar, it's called normal CDF on the calculator. And I've got a video on how to do that in Canvas if you want to go watch that. But this is nice. It's online. And the other thing I really like about this applet is it gives us the picture of the normal curve. Okay, so let's talk about how to use this applet here. I'm going to break this off. I'm going to come back to WebAssign. Here we go. So yeah, you'll see in his videos, it's not hard to do question number 1 with a table, but how do we do it with that applet? So let me come up. And so you have two kinds of normal distributions. One is the standard normal distribution, and that's whenever you have a z-score, that's going to be the standard normal distribution. That's going to be the mean is 0 and the standard deviation is 1. Okay, so if you got a z-score, you're going to use the standard distribution, standard normal distribution. So what we're looking for this one, what's the probability? What's going to be the shaded region for when a z-score is less than 1.86. So that less means below, and you're going to type in 1.86 and click someplace, and that's going to be the answer that WebAssign is looking for. You could almost probably copy and paste it in there. I mean, sometimes the decimal places aren't right, so keep that in mind. But usually this nails it. Okay. Um, so that's how we do A. Now for B, it's greater than. Now, if you were to do this with a table, and if you've watched the table videos, you'd have to go look up here. Let me go below 2.43, and you would get this value off the table. And then because we want greater than, we're just going to do 1 minus that answer. But the cool thing about this applet, since we're looking for greater than, we want above 2.43. And there's that probability. It's not a very big probability either because there's more than 2 standard deviations out, but that's what's looking for. And then here's the beauty of this applet. And when they're looking for between, doing it by tables, you'd have to go find the probability for negative 2.31. You'd have to go find the probability for 1.869 and then subtract them. Here we can just go between, type in negative 2.31. 1.69, and that's the probability. And you see how it's in between those two z-scores, and that's what they're looking for. Okay, got to usually in this calculator, you don't have to click recalculate. Sometimes you do. You do got to make sure that you clicked on the right option here. Yeah, we know this is between because z is in between two numbers. Okay, so I won't bother with that one. This says what's the probability? And people always have a hard time with this one. You could go use the applet with this and figure it out, but I mean, really, this is a thought kind of question. So let's talk about how to do that without an applet. And you can go check and make sure that I'm not all wet if you want. So this says I've got some z-score. I don't know what that z-score is, but I got some z-score. And I know that less than that is 0.95. So that shaded area is less than 0.95. Well, if 95% of it is less than that, doesn't that mean, here, let me go to a different ink. Doesn't that mean 5% is bigger than that? So 0.05 is up in the separate tail? Because then they tell us, what if you're between those, that same, whatever z-score that is, what if we make it be a negative z, make it negative? So that means it's down below 0, right? It's down below the middle. So the same tail area is here. So if that's 0.05 also, because these things are symmetric, what percent's in the middle? And you can think, well, if I've got 5% here and 5% here, that means 90% is going to be here. So the answer for this question is 0.9. Okay. And that'll work for anything. I mean, this question in particular. Okay. So then I'm going to clear this out. Let's see. Okay, so now they gave me a probability. They gave me a percentile. They're going to tell me what z-score it is. So if you go back to David Lane, the David Lane applet, I can just Google David Lane normal and it usually comes up. Okay, you want to make sure you add the word normal because there's a white supremacist back, probably in the 90s, maybe early 2000s, maybe it was earlier than that. And his name was David Lane. So if you just Google David Lane, you got his stuff, and you don't want to see that stuff. He's dead now. Um, he died a few years back. Okay, here. So I want I want this here. I want to be able to see the come on. It's one thing about this screen is a little small. Just a minute, guys. I'm going to stop my share and let me come back and do it this way. Where's WebAssign? Right there. And then here's the applet. Okay. And then I'm going to come back to Zoom and I got to go back to the meeting and then I got to share my screen again. Okay, and hopefully I've got it. Oh, come on, come on, come on, come on, come on. Give me. Okay, here we go. So the 85%. So what you can use this calculator for it. Now, what's different is all these problems we looked at so far gave you a z-score or pretty much gave you a z-score. This, they're telling me a percentile. So that's one of these shaded areas. So because we don't want a probability, which is an area, we want a value from an area. So we choose that selection. Then they ask you for the probability where we're looking for the 85th percentile. So the area is 0.85 and we want to go below it because that's what it is. And I don't know how I see the double periods. There we go. So that's the z-score that's at the 95th percentile or 85th percentile. Okay, much easier than using the table where you got to go inside the table, look for 0.85, go get the z-score. Okay, so I encourage you to do that. So make sure you check value from an area. If you're going back to having z-scores, you got to change it back to area from a value. Okay, this is something that people miss and then they get frustrated. So this one says, I know you can't see the whole thing, but it says find the z-scores that delineate the middle 99%. Well, we want between, right? The error we want is 0.99. So we're going to check between, and there's the two z-scores. And notice they're exactly the same. It's symmetric. So from negative 2.576 and positive 2.576. That's a number we'll see often here after this week as we come on. Okay. So that's how you do number 5. And now we're still talking. Now we're no longer in the standard normal curve because you see how I know that is they aren't telling me any z-scores. So Dr. Stevens is going to have you find the z-scores for all these and then go use the standard normal curve. The beauty of a normal curve calculator, a normal CDF calculator, is you don't need to do the z-score conversion. All you got to pay attention to is, let's see, we get a mean mu of 9.5 because that's a parameter, and the standard deviation, that lowercase sigma, rather than s, okay, is that. And we want to know here. I'm going to write some stuff down here before I go back to the calculator. We want to know x is less than 10 ounces. For A is that. For B, X is greater than 12 ounces, and C, they want between 10 and 12. So I'm going to go back to David Lane. We're just going to answer these all at once. Okay, well, not all at once, but close. So we want an area from a value because we got values, and the mean now is not 0. The mean is 9.5. And the standard deviation is no longer 1, it's 0.9. I mean, that's close to 1, but this isn't the standard normal curve. And then the first question said less than 10. So we're going to go below 10, and that's the area. That's the answer. That's the probability of getting a potato less than 10. Okay, then they say greater than 12, so we'll go above 12, click again, and that's above 12, very small. So we can see that a potato that weighs 12 ounces is more than 2 standard deviations above the mean. Without even knowing the z-score, we can see that. So we would expect to do that. On a quiz or an exam, yeah, I'm going to ask you to do a well-labeled sketch of a normal distribution. Well, you can go use this applet and grab it right there. Just see how that's a nice, it goes, it's got, well, to the left of the mean, it has 3 standard deviations. To the right of the mean, it doesn't, but you could certainly add that in. You would just have to add 0.9 to 11.3, right? Okay, so that's that problem. Let's come back and look at the next one. Okay. So now they told us the mean, they told us the standard deviation, but they didn't tell us a measure. They told us a probability, the heaviest 5%. So they want the top 5% they want to sell. They want to use the lightest potatoes in a potato cannon. So that's the bottom 5%. And then C, the weights that have the middle 95%. So we're going to go back to the applet, and I'm going to change the mean, because now the mean is, oh, I didn't write it down. The mean is 8, standard deviations 0.8. Oh, WebAssign's not being very original here. 8 and 0.8. So then I'm going to top 5%. Oh, I'm sorry, I had to go value from an area because we got a probability. That's the area. So for the top 5%, I'm going to put in 0.05, and I'm going to type in my mean of 8, standard deviation is 0.8, and then I'm going to go above because these are the top 5%. So any potato that's heavier than 9.316, he's going to sell to his friends or in the farmer's market. And then below, we want to go the bottom 5%. So these go to the potato cannon, so we don't have to change anything because it was the bottom 5%. I left the probability the same. And those, if the potato weighs less than 6.684, he's going to use them for cannon fodder. And then middle 95%, the middle 95%. So what we'll do is we'll change our area to 0.95 and go between, and that's the potatoes between 6.4-ish and 9.568-ish will be in the middle 95%. Okay, and see that nice black area there shows us that's the middle 95%. Okay, so pretty easy. And remember, the trick for number 7, you got to change value from an area. Okay, and then now 8, 9 are different because now instead of doing a single potato, we get a sample of 4 potatoes. So these are sampling distributions. If you went and watched, oh, let's see, since I've got the screen on, if you should watch, if you haven't, he's kind of quick to follow. I mean, he goes fast. Oh, I'm in student view. Just a minute here. Let me get out of student view. Because I've got it locked. I don't have it available to you yet. Nope. Come on. Um, this guy, this video, this set of videos. You want to go watch this guy's videos. He talks very fast, but he does a fantastic job talking about what a sampling distribution is. And this is where we're going to go after exam 2. I mean, we're going to do confidence intervals, significance testing. It's all based on this. So this is good to get a handle on it. And the only difference is between, and you'll see this here, The only difference between what I just did with the normal curve and a sampling distribution is the sample size affects the size of the standard deviation. And he talks about it there, so I won't go into that. So let's come back to that problem and let's look at number 8. So number 8 says we've got a mean of 7.8. Here, I'm going to write it over here so I can see it. So annotate. So the mean, the mu is 7.8. The standard deviation, well, actually it's that standard deviation divided by 1.3, and n equals 4. So before you do any work, because we got a sample size more than 1, we're going to have to do this calculation here. We're going to take the standard deviation and divide it by the square root of the sample size. So that's going to be 1.3 divided by 2, which is 0.65, I think. Let me look. 1.3 divided by 2. Yeah, 0.65. So that's the standard deviation. And the way we denote that usually is you'll do that standard deviation simple, put a little X bar underneath it, like a subscript. And so the standard deviation is this. It's actually called the standard error in other textbooks. And maybe Dr. Stevens even uses that term. But essentially, it's just the standard deviation for all the samples of size 4 and how they get fixed. Now, we want to find the probability of less than 9.3. And then the second sample, the second part B is has n equals 7. So it's going to change our standard deviation. So we'll come back to that. So I get a mean of 7.8. I'm going to use my new standard deviation as 0.65. And people miss this on exam 2. They forget that it's a sampling distribution and they just start, plugging away with a normal old, and it doesn't work for them. Okay, so don't miss that here. It's not showing up for me, so I'm just going to do David Lane normal, and this is the function on my screen. Oh, there it is, z-score normal table. Okay, so we've got a mean of 7.8. We got a standard deviation of 0.65, and we want to know let's see, I didn't write that down. We want to know less than 9.3. What's the probability of getting a sample of 4 potatoes where the average is less than 9.3 pounds, was it? No, what did I do? I did something wrong. The mean is, yeah, less than 9.3. I didn't. So let's see. 9.3 and then 8.7 here. So this is going to be more than 50%, right? Because it's more than half. So we want to go below 9.3. And look at that. See, we kind of see that. So almost 100% of the potatoes, almost 100% of the samples of size 4 will fall having mean that's less than 9.3. Now, the other one was a sample size of 7. So I'm going to change the 4 to a 7. Here, why don't I erase that answer 2? So it's going to be 7, and I'm just going to do this on my calculator. 1.3 divided by the square root of 7. 1.3 divided by the square root of 7. I'm getting 0.49. See, a bigger sample, the standard deviation is smaller. Okay, and I better write that down in case it should be right on top of the screen. So let me try David Lane again. Let's see. Whoops. Come back and get the pointer, Dan. Come on. Here it is. So the mean is 7.8 still, but the standard deviation changes to 0.49. And then we want to know below 8.7 or above 8.7. We want to know more than 8.7. So we're going to come back and go above 8.7, and it'll show us the graph and it'll give us the answer. So knowing it's more than, I can see it's got a tail area to the right. that helps me realize that I probably did this correctly. And that's a probability. Of course, it's almost two standard deviations above the mean. So that's that's a reasonable answer. So let's see. Let's go back. And I think what we do next is now we're going to go to, well, let's do this one because this one can be confusing. Let's see. Samples of eight. So now we get a mean of 8. We've got a standard deviation of 1.2, but we get a sample size, groups of 6. So our sample size is 6. So here, let me do some erasing. So I get an average of 6 bags. The mean is, heck, I didn't write. Oh, right, it's right here on the screen. 8. And then the standard deviation is 1.2, but because we got a sample size of 6, that standard error or the excuse me, standard deviation for the sampling distribution is going to be 1.2 divided by the square root of 6. So 1.2 divided by the square root of 6. I'm getting 0.4. I guess I'm going to get 0.49 too. I'm going to round to 0.49. And then let's see, suppose you bag, what percent of these bags will have a mean between 7.5 and 8.5? So 7.5 and 8.5. So I'm going to come back here to the David Lane calculator. And the mean is, let's see, the mean is 8. And the new standard deviation is 0.49 again. And we want to know between 7.5 and 8.5. Of course, I wrote 7.5 twice. We'll double check before I do that. So that's that probability of a bag of 6 potatoes having a mean between 7.5 and 8.5 if the mean is actually 8. Okay. All righty then. So that was the one I just did. Now what we're doing into a different kind of distribution, and this is a distribution of binomials. Binomial, it's a categorical variable, right? It's a binomial. It's a binomial distribution here. Let me come back and pull up the textbook so you can see. Okay, here. Share. Okay, in the textbook, we're in this section now, the normal approximation of the binomial distribution. Do you remember how we had to do that condition check where n times p was bigger than 5 and n times q or n minus p had to be bigger than 5? That's make the distribution be normal. If it's not normal, we can't use the normal approximation. If it's a skewed distribution, we have to go use binomial calculator rather than the normal calculator, okay? But if we can get a normal calculator out of it, we're good to go. And it's the same kind of calculation, that we did back in chapter 5 with a normal curve. I mean, with a binomial distribution, those same mean and standard deviations calculation. We can just plug those into a normal curve calculator. So let's come back to WebAssign and let's do this. So first off, let's figure out if a normal curve is appropriate. And of course they gave it to us. We know it's going to be, but let's make sure and so we know how it works. So the probability of success is 0.48. And we're taking a sample of 210 employees. Well, is 48% of 210, that's almost half, is that going to be bigger than 5? Well, it sure is. And then if we do 1 minus that, we get 0.52 times 210. Is that greater than 5? Well, again, yeah. So this is the normal distribution. We can use normal curve calculations to do that. So what we got to do first off is let me do some clearing off. We got to figure out what the mean and the mean and standard deviation of this distribution is. So the mean for these distributions is 0.48 times 210, which is 0.48 times 210. I'm getting 100.8. And then to get the standard deviation for this distribution, we're going to do the square root of 48.48 times 210, which you already know is 100.8. And then we're going to multiply that by 0.52 because that's what 1 minus 0.48 is. So times 0.52. And then we have to remember to take the square root of that. So, I mean, in case you're wanting to write everything down and you're a little lost, when I multiplied those three numbers underneath, I came up with 52.416. And then I took the square root of it and I got about 7 point, how many decimal points do they want? One decimal point. So I got 7.2. Okay. Now they want us to, we got to do a little bit of work here. This isn't strictly David Lane, because they're asking us for a z-score here. So remember, a z-score is the value we're interested in, which in this case is 79 of them were satisfied with their job. So that's our X. So the Z equals 79 minus the mean of 100.8. And this is going to be a negative Z-score, isn't it? Over 7.2. So here, let's do that. 79 minus 100.8 divided by 7.2. I'm getting a Z-score of -3. -3.03. So that's a very low z-score, right? It's way beyond the -2. So this is an unusual, this finding a poll of about 210 employees where only 79 of them were satisfied. That's very unusual if the 48% is true. So that suggests that for this group of employees or whatever they got their company's employees are more unhappy than the average American, and you got some issues going on. You better take care of that, or you're going to have a hard time holding on to employees, right? That's how you interpret that. I mean, uh, yeah. So since the probability, you know what, guys? I didn't answer this question correctly. They wanted to know the probabilities. You probably wondering what the heck I was talking about because I didn't catch that until I saw this answer. Yeah. So we can just go throw this into David Lane. And now because I've got a z-score, we got a standard normal curve. So I'm going to do, I mean, could go back and retype everything in, but since I've got a z-score, mean of 0, standard deviation of 1, and we got a z-score of 3 point, I don't think I wrote that down here. Oh, yes, I did, -3.03. So I'm going to go below, below, below -3.03 I wrote, right? -3.03. So -3.03. And we're going to see that probability is pretty darn low. So what WebAssign will be looking for is 0.0012. Because remember, look at the 9, they'll look at the 1, and 9 is more than 5, so we round up. And that's that standard, and that's the normal approximation to the binomial distribution and how that works. It's not the central limit theorem. It's a because that deals with quantitative variables. This is the normal approximation to the standard deviation, normal approximation of the binomial distribution. We can treat our binomial distribution like a normal curve. And number 12 is the exact same kind of thing. You're just going to do it. It's just a repeat, rinse and repeat of what you got. Okay, so that's what's hard about chapter 6, I think, is the recognizing when you get a sampling distribution, and then which type of sampling distribution do you have. And this David Lane applet, I think, is a wonderful thing. And you're more than welcome to use it on tests and quizzes. And just said if it's to show your work question, screen capture what you got and make sure you indicate what you're looking at for an answer. Okay. All right. This is a long enough video. I'm going to end it and give a yell if you need more help.